Hello all, I wanted to put a little spin on the addition and multiplication properties of equality. The big idea is that if you perform an action on one side of an equation, so for instance, if you add a number to the first expression, you can add that same number to the other side and you've not actually changed the solution to the equation. So whatever x was before, it's still x. It's still that same value. And this is what I usually term balancing an equation simply because that's how I use it. In the sciences, a lot of times you have to apply these properties in order to understand anything about a physical system. So let me just show you how I talk about these things. Let's say, for instance, that we have an equation x plus 4 equals 2. We'll keep it very simple. So what I like to do, of course, is find the variable. In this case, it's x. And then we say, well, what's cramping x's style? Well, in this case, the 4 is cramping x's style. So we need to get rid of it. But of course, you can't just wipe it away. Otherwise, you've changed the solution to the problem. But we say, how is it cramping x's style? It's doing it through addition. So instead of just wiping it out, we have to perform what we call the opposite operation. So if 4 is cramping x's style through addition, then we have to subtract 4. So by performing the subtraction on both sides, we maintain the integrity of the solution. And we can see, pulling this down, x equals, watch this, those are gone, right? 4 plus a negative 4, if you recall from the lesson now, that's 0. That goes away. X equals 2 plus a negative 4. So the solution of this equation is negative 2. And of course, you can go back and actually check that, and you can say, well, our original equation was x plus 4 equals 2. If we substitute this in, negative 2 was our solution. Let's try it, see if it makes sense. Does negative 2 plus 4 equal 2? Well, if we want to practice our number line, 1, 2, 3, 4 negative, 1, 2, 3, 4 positive. We have our negative 2, and then we're going to add to it 4, and you can see the distance between the two is actually 2. And so negative 2 really was the solution for this equation. So let's try one that's a little bit more complex. How about making this up off the top of my head? 4x divided by 3, and I'm not going to overcomplicate anything. But people just seem to not like anything that's written like a fraction. But what we can do is we can say again, we have x is the variable, and we want to say, well, what's cramping x's style? Well, the 4 is definitely cramping x's style, and the 3 is cramping x's style. And you could do this in a couple of ways, but I'm going to do this as simply as possible. And the simplest way is to get rid of this fraction looking thing, right? So how do we do that? Well, 3 is cramping x's style. In what way? Well, by being divided. So what do? You do the opposite operation. This is the key takeaway I want you to get from here. You do the opposite operation. You multiply by 3. don't let it confuse you that I drew 3 dot and then dot 3. It just means I'm multiplying by 3. I could have drawn it on this side. It's the same thing. So 3's are gone. I rewrite my equation. 4x equals 6. Am I done? Absolutely not. 4 is still cramping x's style. How is it doing it? By being multiplied. How do I get rid of it? By dividing. I can either draw a little divisor line here and put 4, but again, dividing looks like this. I've done the opposite operation. I'm going to make sure that 4 no longer cramps x style. And then what do I have? X equals 6 over 4. And then I can simplify that. We'll get to that at some other point. So big takeaway, identify what is cramping the variable style and then perform the opposite operation and do it step by little step.